As we continue to talk about the Earth and the movement of the crust on the Earth's surface, remember we've been talking about plate tectonics and plate boundaries. The Earth is broken up into these major tectonic plates made of both continental crust, where we have the land, and oceanic crust, where we have, of course, the ocean. As we look into these motions that the plate boundaries have, the one we're talking about today is convergent boundaries. In a convergent boundaries, we notice that the plates are moving towards each other. So the plates converge on one location. Now, with all the different types of convergent boundaries, we can see several different crust combinations. We can have an oceanic continental convergent boundary. We have an ocean-ocean convergent boundary, as well as a continental-continental convergent boundary. And again, these are depicting the types of crusts possible at different convergent boundaries. And we notice that these two are fairly similar in their characteristics, whereas the continental has some of its kind of own characteristics. Starting with convergent ocean continent, let's recall what we know about the densities of the oceanic versus continental crust. Oceanic crust, of course, here is our basalt. Continental granite, we know out of their densities that this basalt here is more dense. Granite crust, less dense. So as these two crusts interact, we tend to see then the more dense plate being pulled down underneath the less dense plate, which in this case happens to be the oceanic crust being pulled down underneath the continental crust. So we can get a little visual of what that looks like sped up over time. That oceanic plate is subducted or pulled down inside the Earth's mantle. The less dense continental crust stays then on top. This area is known then as the subduction zone, the place where that old, dense, cold oceanic crust is pulled down into the Earth. That is, of course, my subduction zone. And as it pulls down into the Earth, it goes through the asthenosphere, headed down into the mantle where the temperature starts to heat up. We also notice a main feature in this boundary is the deep ocean trench. This trench forms right where those two plates meet. The subduction zone pulls the one plate downward. The continental crust then stays afloat on top of the asthenosphere, causing this little trench to occur in between those two plates. Now, as that oceanic crust is pulled down into the Earth, we do see the temperature rise and increase, which means we have old oceanic crust being destroyed. As it's pulled down into the mantle and the asthenosphere, temperature heats up, it begins to melt. As it melts, it creates magma then underneath the Earth's crust, or the lithosphere, and that magma over time can slowly rise up to the Earth's surface, creating another feature on top of the continental crust. Notice the location of these features, these volcanic features, happen away from the tectonic boundary. The trench over here is basically the boundary line, showing where those two plates meet. Here, I have my volcanoes forming further away from the boundary, the place where that magma is melting and making its way up to the surface. We call this feature a continental volcanic arc, right? A chain of volcanics happening on the land, hence its name, Continental Volcanic Arc. And again, we notice their location off the boundary. They need to occur from the melting of the subducting plate, and that doesn't happen until it's further down inside of the Earth. Here's an image of a location where we have continental volcanic arcs on Earth, the Peru-Chile Trench, along with the Andes Mountains. You can see in the image there the oceanic crust being pulled down underneath the continental crust, and that magma slowly working its way up till it erupts on the surface of the continent. Now, typically the volcanoes that form within this type of plate boundary are very large volcanoes and very explosive. You saw that example there of the Andes Mountains on the border or on the coast of South America. We also see this type of volcanic activity from Convergent Ocean Continent on the west coast of the United States in the Cascade Mountain Range. This is a picture of one of those mountains, Mount St. Helens, when it erupted in 1980 with a very large blast and explosive eruption. Now, of course, with all these plates moving and volcanoes occurring, we do have earthquakes. This area looking at earthquakes for the Peru, Chile, Andes Mountains, and here we see earthquakes happening for that western coast. At this type of plate boundary, earthquakes typically occur all along that subducting plate as it moves down into the asthenosphere and the mantle. So typically, we see earthquakes happening on and off the boundary as they occur at the trench location, as well as all the way down where that mantle is melting the crust. And we also see them at several different depths. Again, because that plate is subducting, we notice the earthquakes happening both shallow, medium, and deep. The second type of convergent boundary then is consisting of two pieces of oceanic crust. We're still talking convergent boundary, so the plates are moving towards each other. But now that we have two oceanic plates, will we notice something different? They are both high density plates. However, the older of the two plates is going to have a higher density, so we will still notice a zone of subduction with one of those plates. Subduction being a main feature on both ocean-ocean and ocean-continent convergent boundaries, we see the crust being destroyed there. Oceanic plate pulled down, temperature increases. As that plate increases its temperature, the melting starts to occur. Other key features similar to the ocean-continent boundary would be deep ocean trench, again happening where those two plates come together, one subducts, one stays on top. Deep ocean trench occurs right at the boundary of those two plates. Volcanic island arc, again we see a chain of volcanic activity, but now dealing with an oceanic plate, those volcanoes are occurring in the ocean and over time can pop up to form an island chain. And finally, earthquakes again occur at all depths, both on and off the boundary, as they occur everywhere on that subducting plate, creating several different depths and several locations both off and on the boundary. Examples where we can find this type of plate boundary would be mostly in the Ring of Fire. This northwest edge of the Pacific Ocean is nicknamed the Ring of Fire due to its excessive volcanic activity. Alaska's tail is really a chain of volcanic island arcs. You can see on Google Earth here the deep ocean trench with the volcanic islands just off the boundary. We can also notice the same thing with the Japan arc, a very deep ocean trench here. As this plate subducts underneath, it creates a volcanic chain, which is Japan. Our final type of convergent boundary is continent-continent. Okay, still moving towards each other, but now dealing with two continental plates, both least dense. As these two continental plates occur, both of them are too buoyant or have a low enough density where they no longer will subduct. And as those two plates meet, they end up colliding and pushing up against each other. Noticing our main feature here, rather than volcanoes, will be a non-volcanic mountain range. We have no more subduction occurring once those two plates start to collide. As they collide, their continental granitic crust pushes up over time and creates those large mountain features. We also, of course, as they collide, notice faults and folds that occur within the mountain chain. And of course, earthquakes due to all the movement of the Earth's crust. The earthquakes at this type of boundary are slightly different. We no longer have the subduction, so we tend to have only shallow earthquakes. However, they do occur both on the boundary, where the main mountain chain is forming, and off the boundary, again, as those two plates start to collide over time. Because we have no subduction, we are making no new crust, and we are also not recycling any old crust. Most rocks in this area are granitic, as they both were continental plates just pushing towards each other. We sometimes can have metamorphic rocks occur in this area, as all the pressure is building up from the plates colliding over time. The most common example we see of this type of plate boundary is the Himalayan mountain chain on the border of India. Over time, India has slowly crept closer and closer towards Asia and continues to push its way into the Eurasian plate, increasing the size of these mountains every year. Again, convergent boundaries are when we see plates move towards each other. We see very much similarities between the ocean-continental boundary and ocean-ocean, with both subduction and volcanic activity. However, with continental-continental, volcanics no longer exist as the subduction is cut off, and we end up with solely non-volcanic mountain ranges.